This is Advent of Code. It's a really cool website that gives a new Christmas-themed coding problem each day of Advent. Most people use languages like Python to solve them, but I've decided to try and complete it using Excel. I'm going to pick a few of my favourite problems and share my solutions on YouTube, starting with day 6. For this challenge, they gave a list of inputs. It would look something like this, and we had to figure out how they orbited each other. So we were told that this notation means that B orbits COM, and then C orbits B, and D orbits C, and so on, and that creates an orbit map like this one shown here. So you can see J is orbiting E, and then indirectly J is therefore orbiting D as well. The first part of the challenge, given a much larger input, was to count how many orbits there are directly and indirectly. The way I approached this was I put the inputs down in column A, so these are all of my orbits, and I wrote some code to put that into a table. So let's open up VBA. So here I have a macro that essentially goes through this list, and it goes, let's say it takes this first cell, it says, is VM4 in the table already? If not, then add it as a header and as a row label, and then it would do the same for 6C4. There happen to be 1,727 inputs here, so I've just iterated through 1 to 1,727. So let's run that. There we go, it's created my table. Next, I wrote a macro to record the orbits. So here 6C4 orbits VM4. So what I want to do is put an X here to indicate that that is happening. The next one here, 17S, is orbiting 7KN, and so an X will be put here. So let's run that code. There we go, we've now got our orbits marked as well. To answer the first part of the question, how many orbits are there in total, including indirect orbits, we need to count not just the x's, but then the paths they take back to the origin. So let me look at a simpler example. With this one, imagine we were only counting from D back to the origin. We have D is orbiting C, so that's 1, but then C is orbiting B, which means D is also orbiting B. So that's 2 for D, and then C is orbiting B, which is orbiting the origin. So D is also orbiting B and the origin. So D is in fact orbiting 1, 2, 3 different objects. But then C is then orbiting 2, and B is orbiting 1. So we end up having a total of 6 orbits. So I've written the code to do this. Here it is, count all orbits, and what it's doing is it's counting through all of the objects, starting with the furthest away one. So there happen to be 1,728 different objects. I'm going to start here, I'm going to check that X, and then go, okay, that's 1 orbit, now let's find HX8 and see which one that is orbiting, and so on, and count all of the orbits for that item, and then we will move on to the next column and do the same and add that to our count. And you can see that happening here. So for each column we are going to add to our count whatever we get out of this function, and this function here, count O, is saying if there is an X in that column, then tell us which item that is against, so then we can add one to our count and then check the new object to see what that object is orbiting. So I'm going to press F5 to run that code. Now it's not the most efficient code, so it does take a little bit of thinking, but it will eventually spit out the answer. There we go. That was the answer from my inputs. The second part of the problem asked how far you were away from Santa, and it measured it using these orbital transfers. So basically, once you've created your path, how many connections are you away from Santa? Now, the way I looked at this was thinking that they must have at least one common orbit. In this case, the first common orbit they have is D, and the first one you come across is going to be the quickest route to one another. So I decided to map out the paths starting from U, going back to the origin, and doing the same starting from Santa and going back to the origin. And the way I did this is using this macro here. Basically, all it's doing is it's going to find where U is in the grid, in the headers, and then find the X and output what it's orbiting, and then it will repeat that for the new object. So similar to how I counted the objects and the orbits, but this time I'm actually going to make a list of that path. Let's run that code. There we go. So these are the paths. And then what I simply did was use conditional formatting to find duplicates. And I scrolled down until I saw the highlighted ones, and you can see that 59F was the first common orbit, and therefore I can count how far away you are from that orbit and how far away Santa is, and that would give the answer. So if we start at the top, U is orbiting W54, and then it requires 1 transfer, 2 transfers, and so on, 3 transfers. And so you can see on row 5 we're on transfer 3. So when I get to my common orbit, that is 290, so that is 288 transfers. And then Santa takes 259. So I just have to add those two numbers together, and that got me my answer. So that concludes my solution for day 6. If you haven't checked out Advent of Code, do have a look. It's a really cool website. I'll put the link in the description. It's a really good way to practice your programming, and it's just a bit of good fun anyway. If you want a copy of any of my spreadsheets, feel free to drop me an email and I will be happy to share those with you. Thanks for watching.